Our next lesson, I'm going to break into a couple different videos just because there is a lot of material and sometimes you just need a break in between it. So what we're going to do first is go through each of these graphs. All right, these are all what we call parent functions. We'll talk a little bit more about that later. But what you need to know is what their title is. So is it a constant function, a linear, an absolute value, etc.? And what does its general formula look like? So the first one here, letter A, is going to be an absolute value function. And I'm not going to use y, I'm going to use f of x for this notation. It's the same thing as y, but this is function notation. It's more sophisticated. And it's just the absolute value of x. So that's kind of the equation that goes with that graph. Letter B is going to be a square root function. So it's kind of like a half of a sideways u. And you just simply write f of x equals root x. So these are the equations that go with these graphs. We'll just jump to letter E here. Is a cubic. All right, so it kind of looks like a sideways backwards S almost. And its formula is f of x equals x cubed. Letter F, you should realize that's a line, so hence the name linear. And the most generalized form for linear is f of x equals x. All right, letter C is a line, but it's a special line, so it remains constant at the same number, so we call it a constant function. And we'll use this as the equation. So f of x equals some number. We'll just generalize that to k. So it could be 3, 4, 5, 6, whatever. Letter D, should be able to guess this one. So you can see it kind of starts out small, but it gets really big pretty quickly. So we call that exponential. It grows very quickly. And its formula looks something like that. And you would just have a number in B spot. So it could be 2 to the x, 3 to the x, 4 to the x, etc. Letter G is going to be a reciprocal function, and its equation looks like that. And it's important to realize x is not allowed to be 0. So if you were making a table, you can't use 0 for x because you can't do 1 divided by 0. And then last but not least, letter H, we have what's called a parabola here. So it kind of looks like a U. That is a quadratic function. And the generalized quadratic equation is f of x equals x squared. So these you definitely want to have memorized. All right, so we have several definitions that we need to talk about. They're going to kind of relate to what we just did. So we're going to start with parent function. Technically, a parent function is the simplest form of a graph. We are going to manipulate our graphs, so it's important to know where to kind of start. So I want you to think of a parent function like it's a cake that just came out of the oven, right? It has nothing on it yet, it's just plain. We can manipulate it by adding icing and sprinkles and candles. So those would be the manipulations, but it started out as just a plain cake out of the oven. So it's kind of what a parent function is. It's the starting of the graph, and then we can do stuff to it later. We will be doing transformations, which is just simply a manipulation. So we might move the graph over, we might shrink it a little bit, we might flip it. So we're going to learn how to do that. Translation is a type of transformation. It's when you literally just shift the graph left, right, up, or down. So it's kind of like, when you go walking, you're just moving where you are. Reflection is when you're going to flip the graph across a line of symmetry. So you basically imagine mirroring the picture. Vertical stretch is when basically the graph becomes taller or steeper. So you're kind of like grabbing the top and the bottom and pulling it. And then vertical shrink obvious is opposite. So it's like you take the top and the bottom and you push it together towards the x-axis, so it won't be as steep. We're also going to use graphs to identify domain and range. So just a reminder, domain would be all your x values that are in your graph. And if you're making a table, there are X values that you're allowed to plug in. Those are all domain items. And then ranges would be your Y values that are covered by the graph, or things you can get by plugging in something for X. Those are going to be your range. All right, so there's 3 ways to show your domain and range. You can use interval notation. That's what we're going to use most often. So basically, you have to remember for interval notation, parentheses mean not included. Brackets, however, mean included. So once we do an example, I think that'll make sense. If we have a graph that's kind of broken, and again, you'll see that down in one of these examples, you're going to use a U to kind of join the 2 broken pieces together. You can use words. So for example, if your domain is every X value out there, you can write all reals. You could also say all reals so that X does not equal whatever number is breaking the rule. And inequalities, of course, you can say all Y's greater than something, X is greater than something, etc. Or X is between this and this. So we'll kind of practice using those with the examples. It's easier when you do an example of each. So down here it says identify domain and range of each graph below. And then go back to page 1 and we're also going to do domain and range of each graph. The first thing we're going to do is we're going to do interval notation for letter A. So we're going to start with domain. Okay. So if you look at the graph, once you go to the very furthest left point, so that's right here. So that X value is, it looks like -4. So this thing starts at -4. And because it's a solid dot, we're going to use a bracket. If it was open, you'd have to use a parenthesis. And then you're going to just put a comma. So you're going to tell me, okay, that graph covers all these X values up until right here, which is +4. But this time the circle's open at +4, so you're going to leave it as a parenthesis. So that's interval notation, and then we'll just write D for domain. So now we're going to do our range. So now we're going to look at the y-axis. All right, so the very lowest point that's on this little graph would be right here at -4. So this is the lowest point. So the lowest y value is -4. And it goes up all the way to +4. So they both are solid dots. They're both inclusive. So we're going to say -4 is where it starts, and it goes all the way to +4, but this time the dot is solid, so we're going to use a bracket. If we wanted to use inequalities, we'd write something like this. So for our range, any y that is less than or equal to 4 or greater or equal to -4 is shown by the graph. So all y values between here are represented somewhere on the graph. And then for your domain, kind of the same idea. So you're going to have X values that are between 4 or greater or equal to -4. So anything less than 4 but greater or equal to -4. So those are your notations. We'll skip the words for right now, just because they're not as popular. All right, so interval notation for here, we're going to start with domain. Okay, so if you see these arrows right here, that means these guys are going on forever. So all of these X values, they're going to be covered, okay, because it goes on forever and it just continues and flows. So for domain, we're going to write -infinity all the way to +infinity. And you always use parentheses with infinity. For our range, however, it goes down forever, but it's cut off right here. So the highest point is at 4. And I don't see like a hole right here, so it's closed. So we're going to include that. So the lowest point you could get would be -infinity. And the highest point you could get to is 4. And then you definitely want to use a bracket around that since it's equal to 4. So let's say we wanted to use words. So if you have infinity, a lot of times kids use words. So for the domain right here, anytime you have infinity to infinity, you can just write all reals. So your domain would be all reals. So you could show your answer like that. And then your range, you would say all reals such that all your y's are less than or equal to 4. So basically it says every number that's less than or equal to 4 is in the graph, so you're covered. And then last but not least, letter C, if you remember, that's the reciprocal function, all right? And you see right here, this line gets closer and closer and closer to 1, but it never actually touches it. So our domain, in interval notation, it looks like it goes on forever to the left. So we're going to start at negative infinity. But then it's going to get closer and closer to 1, so we have to break it at 1. Right? So we're going to definitely use parentheses. And since this is a line at 1, it never actually touches it, just gets closer, we're going to use a parenthesis there as well. And then what happens is we kind of have a little jump in our graph, and then it kind of picks up again. So what we're going to do is write the U, which stands for union. And the next curve, it looks like it starts just to the right of 1, right, but not actually on that line, and it goes to the right forever. And then our range, if you look here, so the highest point on the left, it looks like it's getting closer to 0, but never actually touching it. So the highest point would be 0, but it goes down forever. So we're going to say negative infinity to 0. And then our graph breaks, and then it comes up here, and it looks like, again, the lowest point is 0, but it goes up forever. So we're going to say starts at 0, but it does go up forever. So that's our range. All right, so if we were using words for this, or domain, so kind of looking at what you have here, basically every number on the x-axis is covered except 1. So I would say all reals except or such that x doesn't equal 1. So x is not allowed to be 1 in this case. For the range, kind of the same idea. So I would say all reals such that, this time it's range, so we want to use y. You can't have 0 as an answer for the y. So it never actually gets to 0 on the y-axis. It gets close to it, and then it jumps and then continues. So that's kind of how you put that in words. So what we'll do next time is we'll go through the beginning examples right here, and we'll go through and do domain and range for all of those.